Hi students, good afternoon. This is Swapna, Mathematics faculty from EDUHUNT, IIT and NEET Academy. So today we are going to discuss about the concept of set theory, which is concept number 3 related to sets and subsets. Okay, subsets concept we are going to learn in detail regarding a set theory. Let's begin our session. So the first definition today of today's class we are going to learn about subset. So what is the first definition we are going to learn about in set theory today, which is subset. So what is subset? Okay, what is subset? A subset is nothing but, let me consider any two sets first of all. Okay, let me consider any two sets. A is equal to 1, 2, 3, 4, 5. I have taken some elements which is there in set A. Okay, and I am also considering the second set and I have named it as B. Okay, I have taken two elements 2, 3 of set B. My wish, right? I have taken set A and B. If you can observe the elements of set A, okay, what are the elements there in set A? Please tell me. 2 and 3. 2 and 3. So these both elements are also existing in set A, right? 2, 3 and elements, any elements aithe B lo unnayo, whatever the elements are there in set B, those are also contained in set A, correct? So in that case, I can call B is subset of A. B is subset of A. Did you understand what I have taught till now? Em cheppanu nenu? B lo unde anni elements, all elements of B, if it is existing in set A, then I can say like B is a subset of A. Correct? Yes. Mari, how this A is related to B? B is called subset of A. How the A is related to B? Tell me. How the A is got related to B? A is called, A is a main set, right? A elements aithe A lo unnayo, B lo unde anni elements తీసుకెళ్ళి A lo ఉన్నాయి. Then B is called subset of A. How A is related to B? Then we call A is superset of B. A is superset of B. This is about subset and supersets. So let's have a glance of the slide to write down the notes. If A and B, okay, are two sets, let me take A and B are two sets, such that every element of A, what I have told, every element of A is in B, then we call A is a subset of B and we write A is a subset of B. This is a notation. Do not get confused, child. Here I have taken some reverts. So let me take another example. A is equal to 2, 4, 6. Okay, A is equal to 2, 4, 6 and B is equal to 2, 4, 6, 8, 10. Okay, so all elements of A is in B, correct? ఇలా కూడా అవ్వచ్చు కదా ఛాన్స్, రైట్? ఐ కెన్ దిస్ టైమ్ ఐ హావ్ గివ్ ఎగ్జాంపుల్ లైక్ A is equal to 2, 4, 6, B is equal to 2, 4, 6, 8, 10 కదా. మరి A లో ఉండే అన్ని ఎలిమెంట్స్ B లో కనిపిస్తున్నాయా లేదా? Yes, it is visible. Then what I can conclude, A is called, this is subset or superset? ఇందులో ఉండే అన్ని ఎలిమెంట్స్ ఇందులో B లో ఉన్నాయి కాబట్టి స్మాల్ సెట్ ఈజ్ సబ్సెట్. సో A ఈజ్ సబ్సెట్ ఆఫ్ B. A ఈజ్ సబ్సెట్ ఆఫ్ B. Then how B is related to A? B is superset of A. B is superset of A. This is how we have expressed. Okay, that is the first point. How we will notate A is subset of B ki mari notation okati undali kada. How we will denote that A is subset of B? we will express that in the form of A is subset of B. A is subset of B. This is a notation. Similarly, B is superset of A. So you have to start with B is superset of A. This is another notation. So these are notations. This is about subset and superset. Please write down the notes. Please have a glance with examples so that you'll have a clarity. Okay. Can I get back to the next one? Chalo? Yeah. So what is my next slide? So I have explained you about even superset also. If A is subset of B, then B is called superset of A. Just now we have discussed, right? The bigger set, the main set is called superset. So let me give an example. A is equal to 2, 4, 6, 8, 10. B is equals to 2, 4, 6, 8, 10, 12, 14. So whatever the elements are existing in A, all the elements are existing in B. So in that case, A is subset of B. This is a notation, right? And how do you express superset? B is superset of A. B is superset of A. This is the expression. Okay, clear? A subset అవుతుంది B అయితే B superset of A అవుతుంది. Simple, right? Next we are going to learn about proper subsets. Proper subsets. So how do you define proper subset? For example, let me take A is equal to 1, 2, 3. Okay, let me take this as a main set. Okay. So, for example, let me take another set which is equal to B. 1 is also set, right? Next, C is equal to 2, D is equal to 3, E is equal to 1 and 2, okay? F is equal to 1 and 3. Next, G is equal to 1, 2, 1, 3, 2, 3. Okay. Next, H is equal to 1, 2, 3. Okay. And I told you null set is a subset of every set. So I is equal to null set or empty set. Kada? So if I can observe how many number of sets are there here? 1, 2, 3, 4, 5, 6, 7, 8. So if I take any one set considering any one example, A is equal to 1, 2, 3. So I can get total 8 subsets of any set A. So నేను ఇప్పుడు ఏం చెప్తున్నానంటే if I have considered some example which is consisting of 3 elements, total I got how many subsets of the main set? This is a main set, right? So I got 8 subsets, correct? Null set ప్రతి set కి subset అవుతుంది because null set you don't have elements in it, right? So null set is a subset of every set, right? So total will have 8 subsets of A. Now what I am telling is proper subset. Proper subset ante enti? Proper subset means take out of 8 subsets you have a same subset, correct? Same set. A is equal to H over this example, right? So proper subsets in the set A is must not be equal to H. If you consider any set, whatever you consider a main set, you will have its own subset, right? That is called reflexive property. Antena? So 1, 2, 3, for example 1, 2, 3 ikkada teeskunte the same 1, 2, 3 also becoming a subset of the same set. అలా ఉండకూడదు. You should not get the same A. If you are taking B as a subset of A, right, B must not be equal to A over here. If I want to narrate with an example, A must not be equal to H over here, right? The same set should not become a self subset, right? That is called as a proper subset. Proper subsets. Am I clear with this? So if you are considering any one set, you can write like 2 power of n subsets. So if you want to give a narrator formula, how many number of subsets can be existing for one main set? So here it is a proof. So if you have 3 elements, if n is equals to 3, if n is equals to 3, I can create 8 subsets over here, right? If n is equals to 4, I will have 16 subsets over here. You can take out one example and you can prove it off. Okay. So how I am going to conclude in the sense, if you have n elements, 2 power of n subsets will be there, 2 power of n subsets will be there for main set, right, for main set. Am I clear? So that is what I am going to explain you in the next slide. Number of subsets. So what I have explained you out, number of subsets. If you have 4 elements, you just tell me now, if you have 4 elements, how many number of subsets will be there for this? 2 power of 4, right? What is 2 power of 4? Which is 16 subsets you are going to get from this. Okay? Yes? So that is what here they have mentioned here. If a set A has n elements, okay, then the number of subsets is going to get like 2 power of n. And what are the proper subsets? What are the proper subsets? If you could observe the previous example, right? So how many number of proper subsets there? If H has got eliminated from this, so you'll have like 1, 2, 3, 4, 5, 6, 7. So proper subsets were 7 because A is not equal to H over here, right? That is a definition of proper subset. So how many number of proper subsets should exist? Proper subsets, like the number of proper subsets should be n is equals to 7. So that means as per the above example, right? If you are having n elements, how many number of proper subsets will be there? 2 power of n minus 1. This is nothing but proper subsets, number of proper subsets. Am I clear up to this extent? Next, what is a power set? What is a power set? So if you have gathering all the subsets of a main set is nothing but power set, I can say it off, right? So just now you have written, let me take A is equal to 1, 3, 5. Okay, what are the subsets of it? Number of subsets is how much? 2 power of 3 is equal to 8. Very good, right? Because you have cardinality of A is how much? N of A is equal to 3, correct? N of A is equal to 3. So 2 power of 3 is equal to 8 number of subsets I have to get it now. So all these subsets, if I gather at one place and put it in the braces, that is nothing but a power set. If you collect all the subsets of together of a main set, that set is nothing but a power set. Okay, so let me express it out. So what are the sets here? Empty set, okay, B is equal to 1, C is equal to 2, sorry 2 is not there, second element is 3, Next D is 5. E is nothing but 1 comma 3. Next F is nothing but 3 comma 5. Next G is nothing but 5 comma 1 and H is nothing but 1 3 5. So 1 2 3 4 5 6 7 8. So total you have 8 subsets. These are called A, B, C, D, E, F, G, H are representing power set. This is nothing but a power set. Putting all the subsets and of a main set, that is defined as power set. Am I clear up to this? So we'll get back to next one. Next, what are the properties of subsets? What are the properties of subsets? So here we'll talk about properties of subsets. Let me take any 3 sets, okay? Any 3 sets. For example, let me take A is equal to 1, 2, 3, 4, okay? Set. First example. B is equal to 1, 2, 3. Here in this case, B is a subset of A, correct? B is a subset of A. Why? Because 1, 2, 3 are the elements which are already existing in A. Now if I just got change like A is equal to 1, 2, 3 and B is equal to 1, 2, 3, 4, this time we have like A is a subset of B. Avuna? Because A is a small set, all the elements of A are also existing in B set. A is a subset of B. Can I say like A and B are both equal? Please observe from the example. A and B both are equal. So from these I can say like A is equal to B. I have just explained out with an example. So from the above example, you just please observe, if A is a subset of B and B is a subset of A, then I can say like A is equals to B, right? A B ki subset ayi, B A ki subset aite, then both sets are equal. That is the first property of subsets. Okay. Next one. If A is a subset of B, A is a subset of B and B is a subset of C, then A is a subset of C. This is called as transitive property, right? A is equal to B, B equal to C, then A is equal to C. This you are learning from your earlier classes, right? That is the second property. Next, as I have told you, in every set, null set is a subset of every set. That will be my, because in null set no element will be there. So that will be obviously subset of every set. This is the most important property of subsets. Next one, reflexive property, right? So what I have told you. So every set is itself a subset, correct? Next, if A is subset of B, then B is superset of A, or you can say like B is not a subset of A, right? For example, take out this example, A is a subset of B. Take out this example, A is a subset of B. From this example, A is a subset of B. B is equal to A? No, right? B is not a subset of A. So that is A B ki subset ainanta matrana B A ki subset avvalsina avasram ledu. So that is another property of subsets. Am I clear? Can I get back to next one? So what are the 5 properties we have learned? A is a subset of B. If B is a subset of A, then both sets will be equal. That will be my first property. Next one is every null set and itself is also becoming a sets, subsets of each one. Okay. Next we'll talk about disjoint sets. What are disjoint sets? For example, A is equal to 2, 3, 5. B is equal to 4, 6, 7. Can you find anything as similar? Can you find any common element over here? No. If you don't found any common element, in that case we can say like those both sets are A and B are disjoint sets. A and B are disjoint sets. Am I clear? So this is the example. If two sets, please note it down. If two sets having no elements in common, then we call such type of elements are disjoint sets. Clear? These are just small things as you are learning first set theory. It's a very easy chapter, but thing is you have to remind up the terminologies. Okay, fine. Next is overlapping. Overlapping means you know, right? One on another. Overlap. The actual meaning of overlap is one on another. That means you'll have an intersection element, right? At least one intersection element must be there. For example, if A is equals to X such that X belongs to N, let me define B is equal to X such that X minus 1 equal to 0. What is the intersection element of these both sets? X natural number auto B intersection element. What is X minus 1 equal to 0? That means X is equal to 1. 1 is both natural number and it is also satisfying the second property. So here we have C is equals to a common element, intersection element, overlapping element. At least one common element must be there. In that case, at least we can call it as an overlapping sets. Overlapping sets. If you found at least one common element, you can have more than one common. Okay. If you have only one common element, that is an example of singleton set. Please keep this in the brain. Okay. But if you have more than one element, that will be an example of overlapping sets. That is a difference between a singleton set and overlapping set. So in the upcoming session, we are going to discuss more about other concepts of set theory and its problems related to it. Meanwhile, you also practice and try to do problems from the worksheet on your own. If not, we'll discuss in the upcoming videos. Stay tuned. Thank you. Bye bye.